Hello. So in this video, I am going to be talking about the engineering behind the chips that can function in the Large Hadron Collider. So as you can see here on the left side, there's an image of the Large Hadron Collider, and it mentions different, um, stuff that the Hadron Collider is made out of, such as the muon detectors, calorimeter, and toroid magnets and solenoid magnet. There's also a TRT tracker, things like that. And here on the here on the right side, there's another image of the Large Hadron Collider, but it shows like how it's made from a different perspective. Shows different layers of it. Like there's a vacuum chamber right here, and then there's a central detector. There's a muon chamber and superconducting coil, different things like that. So now, here I'll explain some background information about the Large Hadron Collider and chips that can withstand these conditions. So yeah, that's what it says here, and um, specifically those that can function in the Large Hadron Collider. Those are the kinds of chips that I'm going to be talking about today. And then just for some like background information, the Large Hadron Collider, it's like a place on Earth that is like very radioactive. It's very intense and extreme. And it's like a very hard environment. Um, in the Hadron Collider, particles move at a very fast pace. Specifically, it's almost at the speed of light. That's something like 3.0 times 10 to the 8th power meters per second. That's very fast. And engineers at Columbia University discovered a way to make chips that can withstand these intense conditions. So basically, they're chips that can, withstand intense radiation. Basically, that's what those chips are. And then that's what I'm going to be talking about in this video. I'm going to be talking about the engineering behind behind the design of these chips. I'm going to specifically be talking about the electrical engineering behind these chips, how they were made. So here I'm going to discuss the design process and its challenges. First of all, I'm discussing what radiation does to silicon and the chips. Radiation is a lot of particles, and they have a lot of energy, high energy, and they move at a very fast pace. Um, what happens is they touch the chip. And when that happens, when they touch the chip at a very fast pace, charge is created. And that's a bad thing. It's negative, because they ruin the logic of the chip. This leads to the chip to stop functioning. And then also, what occurs is the chip, the logic in the chip, it can change from 0 to 1 or from 1 to 0. This is called a single event upset, and it leads to errors in the performance of the chip. And then, there's this method called the Triple Modular Redundancy that can solve this issue. The triple modular redundancy is when there are three circuits and they're all the same and they work on the same exact task, assignment. And then you can tell if there's an error if one chip, one circuit, has a different result than the other two. Then it's known to be incorrect. The one that has a different result. So that the triple modular redundancy is a method to solve this issue of the single event upset. Now here I'll conclude and discuss some other aspects of the Large Hadron Collider and these chips. So what I find interesting about these chips is the design process. Especially this research can be used for various things. They can be used not just for making chips that can survive radiation, but they're also used in many other designs, such as satellites, because satellites they need to be able to withstand cosmic radiation for a very long time. Like, satellites can't be able to glitch. They shouldn't glitch. That'd be bad if satellites glitch. So, they also have to be used in satellites. This research, and it's also this research also provides. It's in general it improves different technology, different electrical devices. It's especially useful in various fields, especially nuclear energy, because the Hadron Collider is a nuclear energy device. And here on the bottom, sort of like bottom right, I'd say, there's another image of the Large Hadron Collider, but here it's more of a graph of what it's like, sort of. It's more of a model here. It's not really the Hadron Collider itself, but it shows what it looks like underground, sort of. So here, as you can see, there's the land and stuff, and there's the mountains in the background there, and the Hadron Collider itself is underground. It's roughly 27 kilometers in, I think, in width. Yeah, in width. And it says different things about it. Like here, it says the collision energy is 13.6 TeV, and here they mention double integrated immunity and stuff, like different features that the Hadron Collider has. Here they mentioned the Facer. It's a newly installed design kind of process in the Hadron Collider. This is the Atlas, and this is the CMS. This is this Alice, I think it says. Different parts of the Hadron Collider. So yeah, that's the Hadron Collider. That's it for this video. I hope you enjoyed. Make sure to leave a like and subscribe if you enjoyed. And that's all for this video. I'll see you in the next video.